This video is going to be about the classification of numbers. As far as all the numbers you know that you've probably ever run across with, they are all what we call real numbers, okay? In algebra, we're only going to deal with real numbers. As you get more advanced math, you'll deal with some others. Right now, you just need to know two examples of numbers that don't exist in Algebra 1 that we're going to have to deal with. And that's if you have something over 0. We cannot have 0 in the denominator. If that happens, it's no solution, the earth explodes, we all die, you cannot use that, you may not have 0 in the denominator. Numerator, great, the answer is 0. 0 divided by anything is 0, no 0 on the bottom, no bueno, don't do it. Okay? The other example is have a square root of a negative number. We'll learn in Algebra 2 that those are called imaginary numbers. We're not going to deal with that in Algebra 1. So if you ever have a 0 on the bottom, or you have a negative underneath the square root, you're done. No solution, problem's done. We'll deal with that in Algebra 2. Okay, so with these two exceptions, everything else you're going to see are going to be real numbers. Now, real numbers have two different classifications, okay? You can have rational, or you can have irrational. It's better to talk about irrational because there's only a couple examples of those. An irrational number goes on forever and ever and ever, and it doesn't repeat and it doesn't have a pattern, okay? Repeated numbers, those are cool, they're rational, okay? A number that has a pattern, 3.2121221 or something like that, there's a pattern, cool, rational. It's only not cool if it doesn't have a pattern. The most famous example of that is pi. You could go on forever, there's never going to be a pattern. That's crazy. It's so crazy, it's irrational. Okay, so we can't have that. But there are other numbers that will also do that, and that is a square root of any number that's not a perfect square. Square root of 9, well, we can do square root of 9, that's 3, so that's fine. But we can't do square root of 5. Plug it in a calculator, you're going to see that's going to fill up every space. It doesn't matter how big the calculator is, it's going to fill up every space. So the only examples of irrational numbers is pi and the square root of a non-square. Other than that, every number you see is going to be rational. That could just be a number, it could be a decimal, it can be positive, it can be negative. Also, if you have a repeated number that goes on forever and ever, that's rational too. The real definition is a rational number can be written as a fraction. This can be written as 3 over 10. Try it, see what you get. Sorry, 1/3, 1 divided by 3. See what you get. If you go 1 divided by 3, you'll get a number that looks a lot like that, and it'll go on forever, okay? So these cannot be written as fractions. These could be written as fractions. And we can show you later, or in pre-algebra, they show you how a repeated number can become a fraction. We're not going to do that right now. We're just kind of defining. Great. So if you see a decimal and it doesn't repeat, it's rational. So there's a couple more. Out of the rationals, you can have what we call integers. Okay? And an integer is basically anything that doesn't have a decimal. And it can be positive or negative. So -3, -2, -1, 0, 1, 2, etc. These are all integers. Okay? So those will all be great. Within the integers, you can go even further with this. We have what we call whole numbers. I'm going to go over here just so that there's room. Whole numbers. And we also have what we call either natural, or we can call them counting numbers. Some books do them a little different, but they're kind of the same. Natural numbers just mean positive numbers. 1, 2, 3, 4, 8, 7, whatever. Whole numbers are natural numbers, but it includes 0. So think about it. 0 looks like a whole. It's a whole number. So we can play with the word 0 a little bit. But 0, 1, 2, 3, etc. That's going to be a whole number. Not much difference between whole and naturals. Okay, it's just that 0 in there. But these all have to be positive. Okay, so let's give a number. -6. Well, it's not natural because it's negative. Can't be a whole number. Well, it's an integer. Okay, because it doesn't have a decimal. So it's an integer, it's rational, and it's real. Okay? 5.643, done. Well, it can't be any of these because it's a decimal. So it's just a rational number. It's a rational, real number. That's all we would say. Okay, so that's how we define numbers. I've got a worksheet on maxtutorials.com that has this in maybe a cleaner flow chart that'll help you, and we'll also have some problems that we'll work out to define some numbers. But other than that, that is a classification of numbers.